Alrighty. So, unfortunately for you, I made a decision last night. No, but you're gonna have a quiz on Monday. Yeah.
And you're not even here?
Yeah, that's why.
Oh.
Makes it easier. I feel better. I feel better doing it this way than I did the other way. So, you will have a summative quiz on Monday.
It's all about me.
There'll be a couple of just solving ones. There will be a 3x3 in there. I can guarantee you that. Okay? There will be a 3. You got to solve a system of 3 equations, 3 unknowns. Because from the last quiz, you need work with those. Okay? So there will be one of those, and then there will be a bunch of matrix type stuff in there. So yes, there'll be a combination of everything. Okay? And that's good practice for the quiz or for the test next week Friday. So, okay, what's up? You got it figured out? What is it? Rows by column. What's the one rule of matrices? The one rule of matrices is rows by columns. Side note, before we get going on this too, this week's worksheet, the pink worksheet this week, won't be due tomorrow. Okay? It's due Monday. Because tomorrow we're learning stuff that I haven't on there yet. So I'm not going to have you quick do it at the end of the class, kind of do it at the end of the day. So that pink worksheet isn't due until Monday. Okay? We'll just push everything back a day. Okay? So the one rule of matrices is rows by columns. Dimensions are rows by columns. Addresses are rows by columns. If you have your phone out, it's rows by columns. Yeah, all that fun stuff. That's not a way. That's just on your desk that you're going to open it in like 3 minutes when I turn around like this. Okay? Right? So we've got those. Rows by columns, rows by columns, rows by columns. Everything with matrices is rows by columns. Especially today when we get into matrix multiplication. Okay? Matrix multiplication is 198,000% rows by columns. Okay? Which is pretty impressive, being that you only go 100%. Okay? So, we did scalar multiplication on Monday. That's where we had the number in front of the matrix, and we distributed it into all of the elements of the matrix. Okay? That's scalar multiplication. Matrix multiplication is different. They are not the same thing. Okay? So now let's multiply matrices. The very first thing that you need to do when you are multiplying matrices is you have to make sure that you can do it. Okay? And the way that you make sure that you can do it is you have to look at the dimensions in order, left to right. Okay? Because, just so you are aware, order matters. The order that you multiply them in, left to right, matters. So what I mean by that is, normally you've got 2 times 3. Oops, I shouldn't use the x. Normally you have 2 times 3, and that's 6, right? And that's the same as 3 times 2, right? You can flip-flop. Order doesn't matter in normal multiplication. In matrix multiplication, because of our first rule, rows by columns, the order that you multiply in matters. Okay? So order matters. You can't just flip-flop your matrices and expect to get the same thing. Can't happen in matrices. Okay? So what we do is we look at the dimensions of the left matrix, and we write them out, 3 by 2. Then we write out, right after that, the dimensions of the right matrix. And in order to be able to multiply these matrices, these two middle dimensions must be the same. If they aren't, you cannot multiply. So if those middle dimensions are different, it is not possible. You cannot multiply those two matrices together. If they are the same, then the nice thing is that the outer two dimensions, the leftover dimensions, this one and this one, give you the dimensions of your answer. And we're going to use that when we start. Okay? So a very important step that you need to do every single time. You have to see if you can do it. Because if you can't do it, there's no point in even trying. Okay? Save yourself some headaches, some confusion, and just follow this first thing to do. Okay? All right. So let's look at these. If my left matrix in my multiplication problem was a 2 by 3 matrix, if my right matrix in that multiplication problem was a 3 by 5 matrix, can I multiply them together? Why? The two middles are the same. These two right here are the same. So yes, we can do it. What is going to be the resulting dimensions? 2 by 5, because it's what's left over in that order. So middle two numbers, I can't stress this enough, have to be exact. And the outsides then give us that. Can I multiply those matrices? Why not? Middle two numbers are not the same. Only do that. Now, in this particular case, if I flipped them around and multiplied them in the reverse order, so if I made the right matrix the left matrix and so on, could I then multiply them? Yes. Then I could. Because then, in that case, it would be a 3 by 2 times a 2 by 2, and then I have those the same. Now I can do that. Okay? So again, in one order of them, it doesn't work. But if I reverse the order, it works. So order matters. All right. So here is how you multiply matrices. So step number 1, you got to see if it works or not. If it doesn't work, you're done with the problem. If it does work, you should find the resultant dimensions. Okay? So, this left matrix, what are the dimensions of the left matrix? 3 by 2. Rows by columns. 3 rows, 2 columns. Rows are horizontal, columns are vertical. So this is a 3 by 2 matrix. What are the dimensions of the right matrix? 2 by 1. Okay? 2 rows, 1 column. Can I multiply those 2 matrices? Yep. What are the results going to be? 3 by 1? Okay. I'll pause here to make sure that you guys get it written down. So write it down. Don't scrunch it. Give it some space. And then we'll go from there. Okay? So now that you've figured out that this matrix multiplication can work, and you have to do work now, what I strongly suggest is that you then draw yourself a large 3 by 1 matrix. So now you've drawn yourself an El Grande 3 by 1 matrix. Step 2 says, now let's use the addresses of each resulting element to set up the multiplication. Remember, addresses are rows by columns, right? So this is row 1, column 1. This is row 2, column 1. This is row 3, column 1. In terms of those addresses. What that also is this is going to be, oops, I'm sorry, I put that wrong. I put 1 and 2. Now I see why you guys were all looking at me. 1, 1. What this also tells you is that you are going to take row 1, here is row 1, and you are going to multiply it with column 1. Here is column 1. So you're going to take 5 times negative 2, and you're going to add it to 3 times 3. The elements from row 1, you spin around in your brain, and you multiply them by column 1. With me? Okay. This is row 2, column 1. So now you're going to take row 2 and multiply it by column 1. So that's going to be negative 1 times negative 2 plus 2 times 3. Lastly, you're going to take row 3 times column 1. Row 3 is here, column 1 is there, so that's going to be negative 4 times negative 2 plus 0 times 3. So that's going to be negative 10 plus 9. That's going to be 2 plus 6. That's going to be 8 plus 0. Which means that your resulting answer, your final answer, is going to be a 3 by 1 matrix. And it's going to be -1, 8, 8. Let that sink in. Take a drink of my ice cold, pure refreshing water. Questions? Rows by count. Everything is rows by count. Don't think I have one down here. Nope, I don't. Fantastic. You want to try one on your own, or do you want me to do this one because now I got a second count? Let's do it together. Okay. Yeah, we'll do this one. Step number 1 says, I got to figure out, can I or can't I do it? Dimensions of the left one. 2 by 2. Dimensions of the right one. 2 by 2 again. Can I multiply a 2 by 2 matrix by a 2 by 2 matrix? Yes, and my resulting dimensions are going to be so I'm going to draw myself a big 2 by 2 matrix. This address is row 1, column 1. This address is row 1, column 2. This address is row 2, column 1. This address is row 2, column 2. So I take the first row times the first column. 4 times 5 plus -3 times -1. Then I take the first row times the second column. 4 times 0 plus -3 times 3. Then I take the second row times the first column. 2 times 5 plus 1 times -1. Then I take the second row times the second column. 2 times 0 plus 1 times 3. Now I just got to do the math. So that's going to be 20 plus 3. That's going to be 0 minus 9. That's going to be 10 minus 1. That's going to be 0 plus 3. 20 plus 3 is 23. 0 minus 9 is -9. 10 minus 1 is +9. 0 plus 3 is 3. Questions, comments, concerns, clarification? You try one on your own. Julia, you look confused. Is it doable? Why not? Two by two. And those two aren't the same?
No.
They're not. Not possible. And you'll get that. Okay? That's a viable thing. A 3 by 2 matrix cannot be multiplied by another 3 by 2 matrix. Okay? You don't just multiply corresponding elements. Okay? You gotta multiply rows by columns. Rows by columns. That's why it was such an important rule that I gave you on Monday. Okay? So, with that being said, I would like you to find A times B, and I want you to find B times A. Go for it. So, AB. So, A is a 2 by 3 matrix. 2 rows, 3 columns. B is a 3 by 2 matrix. 3 rows, 2 columns. So, can I multiply A times B? Well, that would be a 2 by 3 times a 3 by 2. Yes? Yes, I can do it. Result is going to be a 2 by 2, right? So let's draw ourselves a big two by two matrix. So this is row 1, column 1, row 1, column 2, row 2, column 1, row 2, column 2. Okay? So I'm going to take the first row times the first column. So that's going to be 1 times 6 plus negative 3 times negative 5 plus 7 times 3. Row 1 times column 2. 1 times negative 4 plus negative 3 times 2 plus 7 times 1. Row 2 times column 1. Negative 1 times 6 plus 2 times negative 5 plus 0 times 3. Row 2 times column 2. Negative 1 times negative 4. 2 times 2. Zero times 1. Six plus 15 plus 21. Negative 4 minus 6 plus 7. Negative 6 minus 10 plus 0. 4 plus 4 plus 0. 21 plus 21 is 2. Negative 10 plus 7 is negative 3. Negative 16 plus 0 is negative 16. 8 plus 0 is 8. I get the 2 by 2 matrix. 42, negative 3, negative 16, 8. For my, that was A times B. Yes? Anybody with no's? Let's figure out where we had a no. Everybody got it? Okay. All right. So then now we go to B times A. So now that's going to be, B is a 3 by 2 matrix. A is a 2 by 3 matrix. Is that doable? Yes? And it ends up being a 3 by 3. So let's see if I can go there. Give myself a little more space to make my big old 3 by 3. I know, mean. Two, 3, 3, 1, 3, 2, 3, 3. Okay? So now it's going to be, in my brain, it's going to be reversed. Okay? To make it easy, well, let's see if I can make it easy on this. Can I go like that? And we're still staying in the same order. Okay? So, row 1, column 1. 6 times 1 plus negative 4 times negative 1. Row 1, column 2. 6 times negative 3 plus negative 4 times 2. Row 1, column 3. 6 times 7 plus negative 4 times 0. Row 2, column 1, negative 5 times 1 plus 2 times negative 1. Row 2, column 2, negative 5 times negative 3 plus 2 times 2. Row 2, column 3, negative 5 times 7 plus 2 times 0. And then row 3, column 1 would be 3 times 1 plus 1 times negative 1 times column 2, 3 times negative 3 plus 1 times 2, and times column 3, 3 times 7 plus 1 times 0. Let's see, that's 6 plus 4, that's negative 18 minus 8, that's 42 plus 0. Negative 5 minus 2, 15 plus 4, negative 35 plus 0. 3 minus 1, negative 9 plus 2, 21 plus 0. So B times A is going to be the 3 by 3 matrix 10, negative 26, 42, negative 7, 19, negative 35, 2, negative 7, 20. Yes? Discrepancies. Questions? Okay. Rows by columns, rows by columns. Again, this just goes to prove that the order that you multiply them matters. Okay? If order didn't matter, we would have gotten the exact same matrices for here.